Lesson 55, Advanced Abstract Equations, Word Problems, and Quadratic Equations. All of these introductory headings sound more difficult than they really are, and I think it's just to make it look like you're really smart when you know how to do them, or really dumb when you read the topics. It's like, I have no idea what they're talking about. So,
but then
anyway.
then you're really smart.
But afterwards, you're like, that was stupid. That was so easy. Why did they give it such dumb names? Okay, anyway, abstract equations. Equations that contain many variables and don't have any numbers are considered abstract. Okay? Because when we're talking about letters, you can't put a numerical value to a letter necessarily, so they say they're abstract because yeah, they're full of stracts.
They're just abstract.
And you just don't get them. So, for instance, if I have a over y plus c over m equals d, that's an abstract equation. Okay? So, when that happens, and I say, okay, on this one, let's see, let's solve for y. And then you have to figure out how to algebraically do these so that you can solve for y. Anybody have any reason why I might want you to learn how to do this?
No.
Because it's going to be on the test.
Because that's a good point, Tim. Actually, guys, it's just giving you practice on how to correctly manipulate symbols around. And when I say correctly manipulate, do it in such a way that when you get the answer, it will be done the correct way to get the correct answer. Okay? So even though there aren't any numbers up there, it's still teaching you how to do the manipulation because, again, you will have to learn how to do the manipulation of these numbers algebraically. Because after you're done with algebra, if you go into higher level math, they're going to assume you know how to do all the algebra. They're not going to teach you how to do this. They're going to say, do these problems here and use the algebra that you learned over the past few years in order to do it. Good luck, and let me know when you're done. And since you already know how to do that, then it'll be easy to do the calculus or whatever it is that you happen to be doing at the time. So let's put one of the advanced abstracts up here. There's pretty much just a procedure to do them. They're not really too infinitely difficult. The difficulty level is finite, although it is a large number. So there's the equation. And what I'm trying to do is have you solve for m. So we're trying to get all of this junk moved over to one side of the equal sign except the m. And when I was in algebra, it was like, oh, that's easy. I'm just going to take all the stuff except the m and move it over. I'd be good to go. Got my answer, and nobody could figure out how I got done with my work so soon. But it worked for me, and I manipulated. What was my problem? I manipulated incorrectly. Now, if I was the one making up the rules, that's how we would do it, and everybody would do it that way, and then it would be right. But I'm not smart enough to be the rule maker. I'm just the rule follower. So that brings us up to solving for m. All right, if I were to give you a fraction, 1/3 plus 1/4 equals x, how would I solve that? Isn't that basically what I've got over here, only I've got letters up there instead of numbers? Yeah, I'm going to find common denominators and then add everything together and end up with my answer. Well, it's the same thing that you're going to do with these over here. Whenever you're given fractions with equal signs, get rid of the fractions. It just makes your life so much easier. It's not wrong not to, but it makes your life a lot easier if you can get rid of those fractions first. Okay, so how do I get rid of those fractions?
You have to multiply everything by x.
Okay. Multiply it all by xm. Okay, go ahead and do that right now. Okay, so when you multiply everything by the xm, you should end up with am plus bm plus yx equals kxm. Did you guys end up with that? Okay. One of the things that the book tries to get you to get used to doing, whenever you have in your numerator or in your denominator two terms separated by a plus or minus sign, before you do anything, put a parenthesis around them so that you know that they cannot be separated. Because one of the things students will do is they won't remember to multiply. Once the x cancels there, they won't remember to multiply the m times the a and the b. They'll just do it times m times a and leave the b by itself. So if you put the parentheses there, it reminds you to distribute the m to both of these here. Kendra?
Why do you not put the M on the bottom? Like, you know what I mean?
Because I'm multiplying the whole thing by xm over 1.
Oh, gotcha.
Okay. So that's just, so then my m's cancel is the reason. All right, so once I'm at this place, I've got to remember, and this is one thing that I struggled with, you got to remember what the heck you're looking for. I'm not looking for y, I'm not looking for x, because normally that is what you're looking for. I'm looking for m. Okay, so the next step is whatever you're looking for, get it all on the same side of the equal sign. And get everything else on the other side. Okay? You're going to move things a different way. Everything's going to work out the same way. As long as you do the math right, you're going to get the same answer. Okay. So you end up with that. Now, next step. Since we have all of the m's on the same side, we take an m out and we're left with a plus b minus kx equals negative xy. So since I want m by itself, I'm going to take all that and put it under here. So that all goes away here, and my m equals that negative xy over kx minus, or plus k.
If you got
plus b.
positive xy over kx, that's the same.
This is the same as xy over kx minus a minus b.
Alright.
Okay? You can take all the negative positive signs and switch them, and you'll be able to get that answer. Okay? So that is doing advanced abstract equations. So, you guys are all advanced now.
Yay!
Life's so much better. All right, let's look at some word problems with quadratics. It's the end, Ben. It's the end.
Why did KX change?
All right. So top of page 239, let's look at that example since it's a story problem. We're looking for 3 consecutive integers. Consecutive means what? Right, one right after the other in a row. 1, 2, 3, negative 1, negative 2, negative 3. So I'm looking for 3. So, give me my first one, Kendra. Give me my first integer. You don't even need a book for this.
0.
X.
X.
What's my second one, Kendra?
X1.
Thank you.
Plus 2.
All right, so there's my 3 consecutive integers. You can use whatever variable you want. Kendra always uses a k for Kendra.
Does she?
So, no.
Except for K's take a longer time.
K's do take longer. X's are a little bit faster.
No, it's boom, boom, boom.
Yeah. But X's are just boom, boom. All right, so I'm supposed to find 3 consecutive integers such that the product of the first and third, is 4 greater, so that means it's bigger, right? How much bigger is it?
4.
So if it's 4 bigger and I want to make it equal, I have to make it 4 less.
Or you could add 4 to the.
I could, but I don't want to. 4 greater than 4 times the second. So, in a perfect world, this is 4 greater than this side, but since it's equal, we have to make it 4 less, so it's the same, Kelsey.
First parentheses will start with 2.
Thank you. How come you let me go that far, people, and you didn't correct my mistake? Okay, should be x plus 2.
Because we trust you.
Yeah,
Maybe we
that's it.
should.
That's the first problem. Trusting me. Okay, so once you get there, then we start doing our distributive property. Oh no, we've got a quadratic equation. What shall we do?
You have to use FOIL and use the answer, and the world's a happy place.
Okay. Any thoughts what I'm going to do with that at this point right there where we're at?
Cancel.
Make all
Not
your
yet.
x's on the
Not yet.
same side.
Yeah, we're going to put everything on the same side.
Equal it to 0.
And make it equal to 0.
Wow.
Okay.
Boom.
So, x squared. What are we going to do with our plus 2x and our minus 4x? Okay, good. And our negative 4 minus 4?
Minus 8.
Ooh, I'm impressed.
No, I'm confused.
No.
No, you're not.
I am.
You move everything to one side. Don't be.
Oh, I thought you said you moved only the X's to one side. Sorry.
No, I'm just trying to confuse you, Erica.
Yeah.
Did it work?
Yeah.
Okay, I win.
You get the credit.
Game over.
Okay, so there's where we are. Now what?
You okay.
We're not going to square root nothing.
I want this square root.
This is easier, Michael.
How are you reviewing right now?
Negative 4, positive 2.
Negative what?
4, positive
Okay, negative 4, positive 2. Okay, so what is my answer? X is?
4.
4,
Positive
negative 6.
Which one is it?
Both.
Both of them.
Both fours.
Okay, so what I'm looking for, 3 consecutive integers. It doesn't say they're even, doesn't say they're odd, doesn't say they're positive, doesn't say they're negative. So we get to do whatever we want. So you have to use some sense to figure out which numbers actually work. In this particular one, if x is 4,
Wait,
what's
so
my next number?
6, 5.
4 plus 1, 4 plus 2. If x is negative 2, what's my next number?
Negative 1 and 0.
Okay, so I have 2 sets of answers. 4, 5, and 6. Negative 2, negative 1, 0. Okay? You need to make sure that you look at the answers that you're given. If you're given 2 answers, sometimes one of the numbers isn't going to work. For instance, if I was giving you a problem like this, asking me to find, and the answer or the x variable ended up being, so given this information, how far is it from here to here? And you got a quadratic equation, you solved it, and you got these 2 numbers. How do you know which one's right?
It's not negative.
It's not the negative 2 because you can't go a negative distance. So you throw that one out, so your answer is the positive 4 because you can go a positive 4 distance. So even when you put the negative 2 in, it's gonna work because we didn't use any square roots. Square roots are what give us those extraneous roots. So, but make sure that if they're asking certain things and it's not possible to get a number that's negative or whatever, or a fraction, how many people does it take to do such and such, and you get 2 1/3? There's a problem there.
Well, in the South, about 200 years ago, slaves
One
were
person
considered
may
the
have
third.